Good morning, guys. Happy Wednesday. Happy Asynchronous Wednesday. Today we are going to talk about solving oblique triangles using the law of sines. Now, one might ask, okay, well, how is this different than when we were solving triangles before? And the key word to this is oblique, okay? When we use law of sines, which we're going to get into today, or potentially law of cosines, which we'll finish up with this week, we are solving for triangles that may not be right triangles. Like if we take a look at this triangle, for example, we know that it is a triangle because we have 67 degrees, 49 degrees, and this missing angle measurement would just be the difference between these two and 180. But how can we use trig to find what's missing in it, the missing side lengths, the missing angles, and etc. And therefore, we use this law of sines. So let's kind of just dive into when would we use law of sines? Well, we would want to use law of sines. First, there's three reasonings here. Right? We first want to use law of sines when the triangle is not a right triangle. Okay, so that's the first key step to knowing when to use knowing when we want to use law of sines. Okay? The second key step is when we're given two side lengths and an angle, we can use law of sines. And the third key step is when we're given two side lengths, we can go ahead and use law of sines as well. Okay, two side lengths and or two angles. Pretty much the key idea here is that you need at least the minimum of two side lengths and an angle, okay? Or you could be given two angles and a side length, and that kind of gets a little funky. So we try not to use some of those examples, but that could possibly fall into play, okay? Now, when we want to use law of sines, it's important, we'll add a fourth bullet point, that our calculator is in degree mode. Okay, and if you think about it, that makes total sense because at some point we could be finding some angle measurements. And when we talk about angles and triangles, we tend to talk about them in degrees. So let's go ahead and let's take a look at our law of sines. Okay, our law of sines is a constant proportion of the sine of angle C all over side C is equivalent to the sine of angle A over side A, which is equal to the sine of angle B over side B. Now, we won't really be using all three of them ever at the same time. We could, but we won't really be using all three of them at the same time. The key is that if you have two side lengths and an angle, you could plug in CA and angle A and solve for angle C, right? So by using this proportion, we're really going back on our algebraic skills and using that idea of some cross multiplication, which I think you guys feel really comfortable with. So using law of sines, I think is actually a really great way to start this unit because it starts us off with something that we feel really confident in. Okay, so knowing what we know about law of sines, let's go ahead and let's just fill in this missing triangle. Okay, so let's just go ahead and fill in the missing components to triangle ABC, okay, from above. So if we want to go ahead and fill in the missing components of triangle ABC from above, the very first thing that we can figure out is angle A, and that's because we can use addition and subtraction here, okay? we know from above that angle A is 180 minus 67 minus 49 degrees. Well, when we use the subtraction, right, we have 180 minus 67 minus 49, which gives us 64 degrees. So that is angle A. Okay, 64 degrees. Sorry, guys. I'm at home today, and I just want to make sure that we can see everything. Okay, so we just found angle A. It's 64 degrees. We'll go ahead and put that in. Okay, and now our next objective is to find side C and to find side A. Now, it does not matter which one we start with because we do have angles for each of them. So let's just go ahead and start with solving for side C, okay? So if we're solving for side C, we can go ahead and use these first two proportions, okay? We can say the sine of angle C over side C is equal to the sine of angle A over side A. But now take a look right here. We actually don't have side A. So we're actually not going to be able to use this proportion. So let's go ahead and use B instead. And the reason why we can use B is because if they're all set equal to each other, it actually does not matter the order that they come in. So we can totally set C equal to B, even though they may not go in the same order down below. So if you look down below, the definition says A, B, C, whereas what we wrote was C, A, B. So they're all interchangeable here. So angle C is the sine of 49 degrees all over side C, that's what we're missing, is equal to the sine of 67 degrees all over 25. Okay, well, when we do some cross multiplication, we have 25 times the sine of 49 is equal to C times the sine of 67. Okay, we can go ahead and divide both sides by the sine of 67. And we get that C is equal to, now when we put this in our calculator, we do want to make sure that we are leaving it as the sine of 49. So 25 times the sine of 49 degrees divided by the sine of 67 degrees, and making sure we close that parenthesis. And we do get 20.49, and we can just round to that nearest tenth value. So we can say that this is 20.5. Okay. And that is side C. So now we can go ahead and solve for side A. So we can say the sine of angle A over side A is equal to, and for this one, it really does not matter if you want to use B or if you want to use your newfound C. We can just go ahead and use sine of angle B just because it was the one that was given to us. So it is the most accurate. For side C, we did round it a little bit, so that can make a difference. So the sine of 64 degrees all over A is equal to the sine of 67 all over B, or I'm sorry, all over 25. Okay, when we cross multiply, we get 25 times the sine of 64 is equal to A times the sine of 67. Okay, we can divide both sides by the sine of 67. And we can plug all of this piece right here into our calculator. And we end up getting 25 times the sine of 64 divided by the sine of 67, which gives us 24.4. And there we have our missing components to our triangle. So law of sines, when do we want to use it? We want to use it when we're solving a triangle that is not a right triangle. So let's go ahead, let's turn the page. Let's begin with some practice problems for today. Okay. So here, for example, problem number 1, our job is to find the side length of AC right here, this X value. Okay. Now we have two angles. We have a side length that we're given. And what's really great for us is that the side length that we're missing, we are given the angle for this already, right? So if we want to set up a proportion, we could say that the sine of 21 degrees, that's this angle right here, angle C, all over 54, right? Because that's the side length that it's paired with, is equal to the sine of 65 degrees all over the side length of AC, because that is that missing one. So it just so happened that we are very lucky in this example problem that the missing components do actually go with what we're given, right? Where the missing side length goes with the angle that we're given, and then these two are also corresponding angles with that side length. So if we want to use multiplication, okay, if we want to use multiplication, we would say AC times the sine of 21 degrees is equal to 54 times the sine of 65, right? Divide both sides by the sine of 21. And AC is equal to, I gotta get my calculator out, sorry guys. AC is equal to, all right, 54 times the sine of 65 divided by the sine of 21 gives us 136.6. We can just round it like that. Okay. All right, so now let's take a look right here. Our job is to find angle A. Well, here we're given an angle and a corresponding side length, so we can go ahead and use that one right away. The sine of 123 over 23 is equal to. Now, if we're trying to find angle X for number 2, sorry, you can move the camera down. If we're trying to find angle X for number 2, it would be the sine of angle X all over, well, angle X goes with this side length right here, side length C. But we don't actually know that. So, what we have to do first is we actually have to find this angle. So let's start down here. We have to find angle C first in order to be able to find angle X. Okay? So let's go ahead. Let's take this into play. Okay? So if we know angle C first, let's get rid of this. Let's see, now this becomes the sine of angle C all over 19. Then once we know angle C, we can just use subtraction to find angle A. Now the reason why we can't use law of sines to find angle A is because there is not a corresponding side length that goes with it. And remember, you need that corresponding side length to create the ratio. So let's go ahead and begin. Okay. 19 times the sine of 123 is equal to 23 times the sine of angle C. So we'll divide both sides by 23, divide both sides by 23. Now, let's keep this in mind here. 19 times the sine of 123 all over 23 is equal to the sine of angle C. When we are solving for angle measurements, we always want to do what? So let's think for a second. Let's pause. We always want to do what? Well, if we're solving for angle C, we need to find the inverse, right? So we would go ahead and take second sine of 19 times the sine of 123 divided by 23 and close that parenthesis again. And if you look, it would look something like this. So we do need to take the inverse of it because we are solving for the angle measurement, right? We're not solving for the side length, we're solving for that angle measurement. So therefore, angle C is 43.9 degrees if we wanted to round that. Okay, so now in order to find angle A, we can just use subtraction. So angle A is equal to 180 minus 123, which we were given, right? Minus 43.9, and therefore angle A is equal to 180 minus 123 minus 43.9, and that should give us 13.1 degrees, which if you look at it visually, that is the smallest angle, so it makes sense that it is that small. Okay. All right, and then last but not least for number 3, if you take a look at number 4, it's asking about the area, and we are going to save number 4 for in class Thursday. Okay, we're going to save number 4 for in class on Thursday. All right, for number 3, let's go ahead and begin. It says, solve the triangle of ABC below and give the answers to the nearest tenth if necessary. So clearly there is no angle or no triangle drawn. So let's go ahead and draw it. It's just a sketch, does not have to be that accurate. I totally get it, okay? If we're labeling this A, B, C, okay, well, angle C is 52 degrees and the side of C is 6. So that goes directly across it, okay? Angle B is 27 degrees and what we're missing directly across it is the side of B. We're missing angle A, so we'll put a theta in for there. And we're missing side A. So we have 3 things to solve for. We have to solve for angle A, we have to solve for side A, and we have to solve for side B. Those are the missing components to this triangle. Well, if we are already given 2 angles, the easiest thing to look for first is probably that missing angle A. We can take 180 and subtract 27 degrees and 52 degrees, and we end up getting that angle A is equal to 180 minus 27 minus 52 is equal to 101 degrees. Okay, easy enough, 101 degrees. We'll go ahead and put that in if we want to, in the triangle. Now, side A, side B, let's get going. If we're solving for side A, the only proportion that we can use is the proportion involving the sine of angle C, which is 52 degrees, all over side C, which is 6, because that is the only full piece we have, the C's. B is missing the side length, A is missing the side length as well. So therefore, we would set that equal to the sine of 101 all over A. Okay? If you cross multiply, you would have A times the sine of 52 is equal to 6 times the sine of 101. Divide both sides by the sine of 52. Divide both sides by the sine of 52. You would put this whole piece right here in your calculator, and we end up getting that 6 times the sine of 101 divided by the sine of 52 is about 7.5. We end up getting like 7.47, but we might as well just round that to 7.5 to make it to the nearest 10th. Okay? And then if we want to solve for side length B, we could use C again, right? We could say the sine of 52 all over 6 is equal to the sine of 27 all over B. Okay, again, cross multiply. B times the sine of 52 is equal to 6 times the sine of 27. Divide both sides by the sine of 52. Plug this right here into our calculator. Sorry that my face in that little box is in the way. Right here, maybe I'll move it over here. All right. And therefore we get that side B is equal to 6 times the sine of 27 divided by the sine of 52 is 3.5. All right. So there we have it. Law of sines. We are going to be using law of sines to solve for, there's nothing on that page, to solve for triangles that are not right triangles. Okay. I think you guys will really enjoy law of sines. It's a lot of proportion work, a lot of falling back on our algebraic skills. Tomorrow in class, we're going to keep continuing on with law of sines. All right, we're going to practice, practice, practice. We're also going to start to include area, right? Because when you think of area of a triangle, a lot of us think of 1/2 times the base times height. But when we're using law of sines, there could be some different components to finding the area as well. So with that, we hope you guys have a really great asynchronous day, and we'll see you tomorrow in class. Bye-bye.